In this question, you must show all stages of your working. Solutions relying on calculator technology are not acceptable. Given that the first three terms of a geometric series are as given, we want to show that 4 sine squared theta take away 52 sine theta plus 25 is equal to 0. Now think about the first three terms of a geometric. AR squared. If you do this term divided by this term, you get R. If you do this term divided by this term, you get R. So in other words, this term divided by this term is equal to this term divided by this term. And we can use that here to see if we can get this quadratic equation. So 5 plus 2 sine theta divided by 12 cos theta should be equal to 6 tan theta divided by 5 plus 2 sine theta. Rearranging, that gives us 5 plus 2 sine theta squared is equal to 6 tan theta times 12 cos theta. That will be 72 tan theta cos theta. So this is going to be 25 plus 20 sine theta plus 4 sine squared theta. And over here, because we know tan is sine over cos, that's going to be 72 sine theta. The cos thetas will cancel. So that's going to give me 4 sine squared theta take away. So 20 sine theta take away 72 sine theta is going to be take away 52 sine theta plus 25 is equal to 0. Now in part B, we're told that this is measured in radians. We want to solve the equation in part A to find the exact value of theta. A really important point here is that theta is an obtuse angle. So let's have a look at solving this. So it's a quadratic. We're looking for numbers that multiply together to give me 4 times 25. So multiply to give 100 and add to give negative 52. And negative 50 and negative 2 will do that. So we've got 4 sine squared theta. Take away 50 sine theta. Take away 2 sine theta plus 25. And let's just split that down the middle. And that's going to give me 2 sine theta. 2 sine theta take away 25. And over here we'll have take away 1. And we'll have 2 sine theta take away 25. So that gives me 2 sine theta take away 1. And 2 sine theta take away 25 is equal to 0. So that gives me sine theta is equal to a half. Or sine theta is equal to 25 on 2. And that one doesn't work because sine theta has to be between negative 1 and 1. That is obtuse, and so that's going to give me theta is 5 pi on 6. Sine theta is a half, principal value is 30 degrees, which is here, and that means the secondary value is 150, which is 5 pi by 6 if we're working in radians. So finally in part C, we want to show the sum to infinity of the series can be expressed like this, where k is a constant to be found. So if we go back to the first term, it's 12 cos theta. The second term is 5 plus 2 sine theta. So my first term, A, is going to be 12 cos 5 pi by 6. And the cosine of 5 pi by 6 is negative root 3 over 2. Need to know your standard values. and that is negative 6 root 3. So that's my A. So to get R, we can do the second term. So the second term being the 5 plus 2 sine theta. So that is going to be 5 plus 2 sine theta divided by the first term, which is our negative 6 root 3. Now, note we know sine theta is a half, so 2 times a half is 1. So that is just going to be 6 over negative 6 root 3, giving us negative 1 on root 3. The sum to infinity then is a over 1 minus r. So that is going to be negative 6 root 3 divided by negative 1 over root 3. Correction, 1 take away negative 1 on root 3. So that is going to be negative 6 root 3 over 1 plus 1 over root 3. So that is negative 6 root 3 over root 3 plus 1 over root 3. And what we can do there is say that's negative 6 root 3 multiplied by root 3 over root 3 plus 1. And root 3 times root 3 is 3 times 6, so that's going to be negative 18 on root 3 plus 1. And now what we need to do is rationalize the denominator. So negative 18, root 3 take away 1, over root 3 plus 1, root 3 take 1. So negative 18 root 3 take 1 over, using a difference of 2 squares here, we get 3 take away 1, which is 2. So that is negative 9 root 3 take 1, which is, root 3 take 1 should be in a bracket there. And so that is negative 9 root 3 plus 9.